Find the partial fraction decomposition. First off, we factor the denominator. In this case, we have a greatest common factor of x squared, leaving us 2x minus 3. This is the basis of our guess when we decompose this into partial fractions. So our whole fraction now we start off with the first factor, and that factor is repeated. Because it's a linear factor, repeated, the exponent, the 2 repeated number, tells us that we're going to need 2 fractions to represent that part of the denominator. One will be x denominator, one will be the next power up, x squared. Because the factor itself is linear, we just need a single variable like a and b. Not variable, constant is what I meant to say. We move on to the next one. The exponent is 1, we don't see it, and the factor is 2x minus 3. Because of the 1, we only need one fraction to represent it, the denominator of 2x minus 3. Because it's linear, we just need a single constant on top. If we had like an x squared plus 5 denominator, then that's the one that would need like an ax plus b generalized linear numerator for the quadratic denominator. But we don't have one of those in this problem. Okay, the next step is to clear fractions. We multiply by the LCD, which is the original denominator, every time. Each fraction, something different will reduce. And so it's a good habit to write what you're multiplying by each term. For example, this first, everything reduces. The second one of the x's reduce. The third one, the x squareds reduce. And the last one, the 2x minus 3 reduces. This gives us the result, negative 9 equals ax times 2x minus 3 plus b times 2x minus 3 plus c x squared. Okay, now interesting thing happens on these problems. Since we have a denominator, we have domain issues. Specifically, x shouldn't be 0 and x shouldn't be 3/2, or else we plug them in, we get divide by 0. Those values end up being the perfect values to use after we clear fractions. So if I let x equals 0 in this equation, I would get negative 9 equals a times 0 times negative 3 is 0. That first one is gone. The second one, b times negative 3, is negative 3b. And on the third one, c times 0 squared is 0. So all we have left is b, and we can solve for b. And for pretty cheap, we get b equals 3. Similarly, if I let x equal 3/2, lots of stuff happens. We still have negative 9 on the left. Sometimes the numerator has an x in it as well, and then we evaluate the left side too. In this case, we are evaluating the left side, but it's constant, so it's staying the same. Plugging in 3/2 into this 2x minus 3 makes 0. 0 times anything else is 0. Second one is 0. The third one, 3/2 squared, is 9/4. So we get 9/4. C times 9/4. If we solve for c, we get c equals, the 9's reduced for negative 4. And we're now out of values that were not in the domain of the original one, so we're out of this really nice stuff happening. There's a couple of ways to continue. What I prefer to do is to recognize, for example, the a is involved with the x squared, specifically 2ax squared. So if I look at the x squared and the c squared and the invisible 0x squared on the left and compare the coefficients, on the left there are no x squareds. On the right we have 2a x squared and plus c x squared. We can now solve for a. A is negative c over 2, and we have c. 4 halves is 2. You could also do what I refer to as a dumb value, just some other value, plugging it in. We get negative 9 equals 1, that would be 2a minus 3a plus 1 here, 2b minus 3b plus 1 here, c. And plugging in the b and the c that we know, you could find a, and it would still be 2. It's dumb because it doesn't really simplify much. Comparing coefficients is a really nice simple equation that you get. The a that we're missing is only involved in the x squared term or the x term. So notice we could do this with the x term as well. This one and this one. If we compared those, there are no x's on the left. We have negative 3a, although uppercase, sorry, and plus 2b. So a would be 2b over 3. If I plug in 3 for b, I again get a equals 2. So you can compare whatever coefficient term, whatever degree, the x squared or the x, that involves the coefficient that you're looking for, or a dumb value. And there's other methods, but this is a nice method to work. So we now have a equals 2, b equals 3, c equals negative 4, and we've established where a, b, and c go. The only thing left that I like to do is write the actual final answer. We have succeeded in finding this out. A is 2, so 2 over x plus b is 3 plus 3 over x squared, and c is negative 4. We can write plus negative 4 over 2x minus 3. That's okay, or we could just do minus and 4 over 2x minus 3. That's your choice. They both would be accepted. So we've achieved finding the partial fraction decomposition. The point of being able to do this is when you get to calculus, calculus of the left expression is much more difficult than calculus of the right expression. All right.